and first grade math night for parents. This podcast is intended for those who couldn't join us on the original evening of the presentation or for those who just want a refresher. The agenda for the evening included the Common Core areas of focus, standards of mathematical practice, conceptual knowledge and operational skills, and addition and subtraction strategies. We also discussed briefly the grade level critical areas. For kindergarten, those are represent, relate, and operate on whole numbers, initially with a set of objects and then later moving to numerals, and also describe shapes and space. The critical areas of first grade include develop understanding of addition and subtraction, develop understanding of whole number relationships and place value, develop understanding of linear measurement, and reason about attributes of and compose and decompose geometric shapes. We also discussed the standards of mathematical practice. These are a separate set of standards. These are not the content standards. These instead are standards of practice that good mathematicians do. There are 8 of them, and these are not explicitly assessed or instructed, but rather they are embedded in our daily instruction, teaching children how to think through like good mathematicians. You'll notice number 1 and number 6 are highlighted blue because these are overarching standards of practice that apply to almost any math problem you work on. Make sense of problems and persevere in solving them, and attend to precision. When we talk about conceptual knowledge and operational skills, we talk about how they come together to complete the understanding. Rather than the strategy or method being assessed, we look at the way students show their thinking or prove that their answer is correct. Through the use of place value and visual models, students have a deeper understanding of the why behind the process, and they can even explain the why. And the ultimate goal, of course, is for students to find answers in the most efficient way possible. The kindergarten math content areas are counting and cardinality, operations and algebraic thinking, number and operations in base 10, measurement and data and geometry. You'll notice that counting and cardinality is only in kindergarten. We do not practice this again in the other grades. The instructional implications of the Common Core standards are less of a focus on rote memorization and more emphasis on number relationships. That isn't to say that memorization isn't important in math, because it is. We do need automaticity with some facts. But when they are in kindergarten and first grade, we're really working on number relationships and visual models instead of rote memorization. To talk a little bit more about the conceptual understanding, I shared the story of a little girl who had proven that she could be successful with symbols without fully understanding what the symbols represent. This little girl had practiced diligently with her flashcards, and one day in school we were practicing sums, and I said, show me or tell me what the answer is to 5 plus 4. And she said quickly, that's 9. And I said, well, can you show it to me? Can you prove it with manipulatives? So she grabbed some cubes and pulled out 5 in one hand and 4 in the other, and put them together and said, that's 9. And I said, well done, let's try some subtraction. I said, what about 8 minus 3? And she quickly answered, 5. And I said again, could you show me with the cubes? So she got out 8 cubes, and then she got out 3 more. And then she moved those 3 away and looked confused to see 8 still there and not the 5 that she had expected. So she scratched her head and looked at me and said, well, I guess it's 8. This is a great example of how a student has practiced facts without a full conceptual understanding. She didn't know how to model subtraction, which many children don't. So this is where we go with kindergarten, with the conceptual understanding before the symbolic. Materials that we use in kindergarten include dot cards. You might see a lot of dot cards coming home or hear your children talk about dot cards. Dot cards are used to develop subitization skills. Subitization means that a child could or an adult could look at an amount, a quantity, and know how many immediately without having to count each individual item. Children ages 3 and 4 should be able to subitize 2, 3, and 4. This would be dots that you might see on dice or dominoes, or simply in a drawing, or simply in if you're holding 3 items. They could look quickly and tell you that is 3 in your hand without counting each one. Dot cards also develop pattern recognition skills. They work on the sense of part, whole, and develop counting on skills. Here is an example of a dot card. A teacher might show this to children for 3 seconds and then hide it and ask, how many did you see? Many children here first see 6 and 1 to say 7. Other children might see 3, 3, 1. There's a variety of things that children see here. Here are other dot cards which are color-coded to really emphasize the part total. We also use a lot of 5 frames, 10 frames, and double 10 frames. This is an example of a 5 frame. It is a rectangle divided into 5 sections, and we use this to build 5 and decompose it. We might use it in an activity like this where we have filled it with red dots and we flash it up quickly and say, how many red dots do you see? Again, reinforcing that subitization to see that there are 2 quickly without counting each one. We might also move to questions like, how many more do you need to make 5? So we're completing the unit of 5. Later we move to 10 frames. The 10 frames are used in the same way, but this time the unit we're working on is 10. How many do we need to complete 10? Children can look at this image and say quickly that there are 6 because they learn that 6 is 5 and 1. Just like 7 would be 5 and 2. Double 10 frames are introduced when we're working on teen numbers. We will work on talking about teen numbers and describing them as one complete group of 10 and some extras or some extra ones. This 10 frame, double 10 frame here shows how later children will use them for addition. With the fact 7 plus 5, you can see that we've made it more meaningful without just showing the 7 plus 5 as numerals. We're also showing it with a visual. Children here now can have the ability to rearrange the dots in any way that makes it meaningful for them. In this picture, it shows moving 1 from 7 down to the 5 to make it a double. 6 plus 6. Many children are good with their doubles. Another possibility would be to move 3 up from the lower 10 frame to the upper 10 frame to complete the 10, to make it a 10 plus 2. And yet another way, some children see 5 on each row of the top row of each 10 frame. 5 and 5 is 10 and 2 more. All of these are acceptable and wonderful ways for the children to visualize a sum and completing a 10. They're great strategies instead of just simply memorizing a flashcard with digits. All of these models lead to a deeper understanding and they lay the foundation for later targets. Let's walk through a couple of our kindergarten targets so you can see how 10 frames and dot cards could help. Compare 2 numbers between 1 and 10 presented as written numerals. Before they're able to get to the written numerals, they have worked plenty with 10 frames and they can tell quickly by looking at a set of objects which has more. Then we lead nicely into the digits. Here are some targets from our OA target, the operations and algebraic thinking. Represent and solve addition and subtraction. So when given an addition or subtraction problem, they need to represent it. They can do this by showing 2 10 frames and how we put them together. Decompose and record numbers less than or equal to 10 in more than one way. So again, dot cards, lots of different groupings to make 10, or the 10 frames. And lastly, find and record the missing addend in a sum to 10. The children, after having worked with 10 frames, they're very good at visualizing, and number 7 has 3 empty spots to complete the 10, to fill the 10 frame. So they learn that 7 and 3 makes the 10. This target is from our NBT, Numbers and Base 10 strand. Compose, decompose, and record numbers from 11 to 19 into 10s and 1s. Again, the double 10 frame has helped with this. The children see a number like 12 as one group of 10 and 2 1s. Let's move on to some addition strategies for first grade, keeping in mind how all of those previous strategies have laid the foundation for these things. When we talk about addition, most people think of this simple 2 flowers plus 3 flowers makes 5 flowers. But there are many more situations that we need to expose children to. This is an example of combining two groups. There are 4 black fish put into a tank, 5 red fish are put into the tank. How many fish were put into the tank? So we are combining two groups. Here's a different type of situation, which is add on to a group. So in this case, we have an existing group, and we're going to add on to it. Katie has 3 antique dolls. Her father gave her 4 more. How many dolls does she have? The part whole is a very common addition situation. We have 4 girls and 6 boys playing in the yard. How many children are playing in the yard? We often use part total diagrams where the children can see how the 2 parts combine together to form the total. When we talk about subtraction, again, there are many different situations. Comparing, we're not on subtraction. This is addition still. Comparing is a very, very difficult type of addition. Barney has 7 old coins. Steve has 2 more than Barney. So how many old coins does Steve have? This is a difficult one for children. But you can see how they've had to line up what they have in common and see the 2 more. Now we're on to subtraction. Missing part is one type of situation. If I have 8 pencils, 5 are on my desk. How many are inside my desk? This is an example where the part total diagram could help. They know the total this time is 8, and they know one of the parts is 5. So they can rely on their addition skills and their dot card skills to know what would go with a 5 to make an 8. Taking away is the most common subtraction situation. I have 8 pencils. I gave my sister 5. How many pencils do I have left? And a child could draw a picture like this to model it. Comparing quantities is traditionally quite difficult for children. I have 8 pencils. My brother has 5 pencils. How many more pencils do I have? Most children want to answer with 8. They state the larger number instead of lining them up and comparing to see what they have in common and how many extras there are. All of these addition and subtraction strategies involve things like making a 10 or decomposing numbers, studying the relationship between addition and subtraction and how they work together, and using easier or known facts. Here's an example of making a 10. If the original problem was 9 plus 6, a student who has worked with 10 frames can easily see how 9 is very close to completing a 10. It just needs 1. So they might change the problem from 9 plus 6 into an easier fact, 10 plus 5. This is an example of decomposing numbers or expanded form. 68 is made of 6 10s and 8 1s. They use blocks like this in class. They later moved to pictorial representations of these blocks, but they're really understanding how a number can be decomposed. That can be used later in 2nd grade. This is a 2nd grade example, but you can see how the knowledge from 1st grade can help here. When adding 2 numbers like 46 plus 12, of course they could line it up like this and use a paper pencil algorithm to solve it. But we want children to become good mental mathematicians and know how to pull apart these numbers and say 46 is made of 40 and 6, and 12 is made of 1 10 and 2. So I can put my 10s together. 40 and 10 is 50, and 6 and 2 is 8. So this allows children to be quicker and more efficient and capable of doing these mentally. Another possibility is thinking addition to subtract. This would be a missing part. They're familiar with this. If the total of 7 and one part is 3, they know how to find the missing part. So they can use that strategy when thinking 7 minus 3. Using easier or known facts is a very common strategy. When given a problem like 6 plus 7, many children will think, well, I know 6 plus 6 because doubles are easy. And if 6 plus 6 is 12, this is just 1 more. So now let's talk about what parents can do to help. Always a frequently asked question. We always invite you to encourage the children not to give up while solving problems. We want to build that stamina and develop their critical thinking skills. Don't give them the answers too quickly. It's so easy to do to jump in when we see them struggle, but try to let them struggle and work on their own way of solving these problems, even if it's not the way that you're used to. And always ask them to think of different ways that they can solve problems. Don't just end with one way. There's always other ways to think through problems. Have children think about their math as they're working in their head and discuss it out loud. Have them apply their math knowledge to a real world scenario at home, such as doubling a recipe or cutting a recipe in half. Or when you're playing a board game, you could ask who's winning or by how many points. Ask your child what if questions, like what if you had 6 cookies and I gave you 1 more? Or what if you had 10 cookies and I gave you 6 more? Ask open-ended questions. For example, there are 10 cars in the parking lot. Some are red and some are blue. What are the combinations you see? When practicing facts, try meaningful flashcards as an alternative to traditional flashcards. A meaningful flashcard would be dot cards or 10-frame cards. You can find these anywhere on the internet. Dot cards you can make. 10-frame cards you could Google and find those, but you could hold up a card for 6 and a card for 7 and ask what the sum is with that visual instead of just the written numerals 6 plus 7. And of course, play games. Card games, dice games, domino games, board games, all of these games are so good at developing the foundation for math. So thank you very much for coming to this podcast. And if you have any questions, feel free to call Lisa Zimmerman or Kim Utakis. We are the math specialists who worked on this presentation. Thank you very much.